So welcome to Learner's Aid. And the focus for this lesson is to explain to you in simple terms and in a very, very interesting way what isomerism is. So if you follow with me or you pay attention to this lesson from the beginning to the end, I'm hopeful that you will understand what isomerism is. And it should be a walk in the park for you. So let's get straight to business. So what exactly is isomerism? Before we try to explain what isomerism is, let's first understand what the word iso is. Then I think understand what iso means will make it easy for us to remember the term isomerism. So you see the word iso, it actually comes from Greek. And the word English actually borrowed from Greek is isos. And isos means equal or same. So English just borrowed that word and combined it with merism to give us isomerism in chemistry. So what is isomerism? It is a phenomenon where compounds tend to have the same molecular formula but different structural arrangement or spatial orientations. That is what isomerism is. So if you don't know what molecular formula is, on our foundation model, we actually explain what it is with displayed formula and structural formula. So you can check the description under this video to have access to the full playlist. So now let's get a better understanding of isomerism using some examples. So check these organic compounds you have on the screen. There are two of them. Let's concentrate on the first one, this. Let's first count the number of carbons present in the first compound. Let's go. We are counting the number of carbons. So let's start. We have 1, 2, 3, 4. 4 carbons in total. So we'll have to write C4 for the first compound. Now let's focus on the second one. How many carbons? Let's count. 1, 2, 3, 4. So we have 4 carbons in the second compound as well. So that gives us C4. Now let's get back to the first compound again. Let's try this time around to count the number of hydrogens present. So let's count. Count with me. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 hydrogens present in the first organic compound that we've revisited. So write H10. So what that means is that for the first organic compound we have on the screen, the molecular formula is C4H10. I hope you get it. Now let's get back to the other organic compound. Now let's count the number of hydrogens. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it also has 10 hydrogens. So it can be written as H10. That's quite interesting. You see that the first compound is C4H10. The second compound is also C4H10. But look at their structure. The structures are different. So in this scenario, we refer to the two compounds as isomers of C4H10. I think that makes sense. Yeah, I think it does. So the C4H10 is the molecular formula. It tells you the number of each atom present in the compound. That's all what it does. And the structure we have at the top are the displayed formulas. You can see that the structure of the compounds look entirely different. For the first one, we have 3 carbons in chain. Then there is 1 carbon sticking out from the second carbon or the middle carbon. But for the second compound, we have the 4 carbons arranged in chains. The structures look completely different, but their molecular formulas are the same. So this phenomenon is what is known as isomerism. Good. Now let's discuss the types of isomerism that exist. What are the types? We have structural isomerism and stereoisomerism. The structural isomerism, also known as constitutional isomerism. What exactly is it? For structural isomerism, compounds have the same molecular formula, but they differ in the connectivity of their atoms, how the atoms are connected. So the example we discussed on the first slide also falls under the structural or constitutional isomerism. So the example we have, C4H10, these are structural isomers because of the difference in connectivity of their atoms. What about stereoisomerism? For stereoisomerism, compounds have the same molecular formula and atomic connectivity. So the way the atoms are connected are the same, but their spatial arrangements in 3D space are different. Well, you might be asking, what does that mean? Spatial arrangement of atoms in 3D spaces. Well, don't you worry. Let's look at this example. We have trans-2-butane and cis-2-butane. I've given you the skeleton, the one at the top, flat, more like 2D. But to make it easy for you to understand, I've given you some 3D rotating models of each of the compounds. So let's analyze the first one, trans-2-butane. Look at the double bond between the two carbons. Now, you will see that there is a CH3 or carbon bonded to 3 hydrogens at opposite sides of the double bonds. That is trans-but2-ene. Pay attention again. We have carbon bonded to 3 hydrogens, 2 of them, but 1 at opposite sides of the double bond. That makes it trans-2-butane. What about cis-2-butane? The CH3 are on the same side of the double bond. So pay attention to the model we have on the screen. As it's rotating, look at where the double bond is. The carbon-carbon double bond, you have CH3 at the same side of the double bond. That makes it cis-but2-ene. All of these compounds that we have discussed so far are C4H8. That is their molecular formula, C4H8. So they are all stereoisomers of the same compound. Now we've discussed what isomerism is and the types that exist. Let's have a look at this table to summarize what we've done so far. So we have the 2 main types of isomerism. We have structural and stereoisomerism. For the structural isomerism, we have subtypes, which are chain isomerism, position isomerism, and functional group isomerism. For stereoisomerism, we have also 3 subtypes. So you can look at them. Geometric isomerism, which are the cis-trans one we already discussed. But in future lessons, we'll pick these subtypes and discuss them more into details. But for now, we'll be focusing on structural isomerism, more specifically chain isomerism in alkanes. That will be the lesson we'll be discussing next. So if you do not want to miss that lesson, hit the like button and subscribe to the channel so that when this lesson is prepared and released, you'll be one of the few people or first people to see it. See you there. But what are we to expect in that lesson? Well, when it comes to structural or chain isomerism, we'll be giving you the definition of it. Then we'll pick a particular organic compound or a particular alkane and look at the various isomers that can be formed from that compound. So I know you would not like to miss it, so see you right there.